So let's proceed with implicit differentiation. Okay, so implicit differentiation. So to find y prime of implicit function, differentiate both sides of the equation with respect to x and then solve for y prime. So take note that when you are going to differentiate y, a term, you should have to multiply it by dy over dx or y prime. So that's the general rule it talks about when it talks about implicit differentiation. So we have here five problems, which is set A, which is find y prime by implicit differentiation, which is number 1, x cubed plus y cubed minus 6xy is equal to 0, and number 2, the square root of x plus y plus the product of xy is equal to 21, and B is equal to y double prime, or the second derivative, that is 1 is the product of xy, or xy is equal to 32, and number 2 is x squared plus y squared is equal to 4, and number 3 is y squared minus 16x is equal to 0. So we'll begin with number 1. Okay, so in question number 1, so x cubed plus y cubed minus 6xy is equal to 0. So we need to find y prime here, or the first derivative, or y prime could be the same as, or it is the same as dy over dx, or f prime of x. So the same lang po yan. So the same notation, y prime is equal to dy over dx or f prime x. So again, to differentiate the term of y, we need to multiply it by dy over dx, or with respect to x, or y prime. And this is implicit because that is not normal, and not normal of an equation, because it involves two variables and it will not be considered. We're considering only to the y function of x at this time. So let's begin with number 1, which is x cubed plus y cubed minus 6xy is equal to 0. So we have to find y prime, or the first derivative of the implicit difference using implicit differentiation. So in this case, so we have the derivative of x cubed is equal to 3x squared plus the derivative of y cubed is equal to 3y squared times y prime. So that is when you're going to differentiate the term y cubed, since that is a term of y, you have to multiply it by y prime at the end. Minus, since this is a product, so we will illustrate here using the rule v du over dx, u dv over dx plus v du over dx. So this is the rule that we're going to use, u dv over dx plus v du over dx. So this is product, or product rule. So this is a product rule, so therefore we have, so this is 6, so x times u. What is our u? Copy u, which is this is our u and this is our v. You copy the u, then the derivative of v, which is y prime, because that is implicit. Then plus v, you copy the v, times the derivative of u, which is x, and the derivative of 0 is equal to 0. So now we have 3x squared plus 3y squared y prime minus, we need to distribute this part, so this becomes 6x y prime minus 6y is equal to 0. At this time, we need to isolate ay isolate po natin yung y prime. So, we need to combine first this one, and we need to transpose this one to the other side. So, we have 3y squared y prime minus 6xy prime is equal to transpose 6y, and this one become negative 3x squared. So now, we have to factor para ma-isolate po natin. So we have here y prime factor. So 3y squared minus 6x is equal to 6y minus 3x squared. So by the use of division property of equality, so we need to divide both sides by this one. So the result of dividing is y prime is equal to 6y minus 3x squared over 3y squared minus 6x. So, in this case, this is still factorable by 3. So, y prime factor, so 3. So, this is 2y minus 3 minus x squared over 3. This is y squared minus 2x. So cancel 3. So y prime is equal to 2y minus x squared over y squared minus 2x. So the result of this implicit differentiation is y prime 2y minus x squared over y squared minus. Okay, so let's proceed to number 2. So square root of x plus y plus xy is equal to 21. Take note, this is a product. So we need to take the derivative of a product. So take note this one, xy. So first is we need to express this one as x plus y raised to 1/2 for us and easy differentiating this one plus xy is equal to 21. So take note, this is our u and this is our v. So take note, this is the product. Okay, so first is we need to find the derivative of this one. So 1/2. So x plus y raised to negative 1/2 because 1/2 minus 1 is negative 1/2 times the derivative of this one is y 1 plus, since this is implicit to implicit differentiation with respect to x, this will become y prime because we're looking for y prime here. Plus, and this is the product, that is u dv plus v du over dx. So therefore, we have x times the derivative of v, which is y prime, plus y copy, and the derivative of x that is equal to 1 equated to derivative of a constant is equal to 0. Next, we have to express this as 1 plus y prime over 2 the square root of x plus y. Diba? 1. And this will become at the denominator, which is 2 the square root of x plus y plus x y prime plus y is equal to 0. So we could express this part as 1 over 2 square root of x plus y. You have to separate this plus y prime over 2 square root of x plus y plus x y prime plus y is equal to 0. So we have to get the y prime. In order to get the y prime, we need to combine first as 1. So we need to have the factor y prime is equal to 1 over 2 the square root of x plus y plus x, and being transposed here, negative y minus, and this will become 1 over 2 square root of x plus y. Next, we have to simplify first. So the LCD of this one, 2 square root of x plus y. So this is 1 plus this 1 divided by 1, that is equal to 2 square root of x plus y times x, that is 2x the square root of x plus y. And we need to simplify also this one. So this is 2 square root of x plus y. And understood, we have 1 here. So 2 square root of x plus y divided by 1 times this negative y. The result is negative 2y square root of x plus y minus 1. Okay. So we could extract this one, y prime is equal to 1 plus 2x the square root of x plus y over 2 square root of x plus y. We could extract the negative. So we have 1 plus 2y the square root of x plus y over 2 square root of x plus y. So since we need to divide this, so equal negative 1 plus 2y over the square root of x plus y all over square root of 2 square root of x plus y here over this will become 1 plus 2x the square root of x plus y over 2 square root of x plus y. So cancel this part. The remaining is y prime is equal to negative 1 plus 2y the square root of x plus y over 1 plus 2x the square root of x plus y. So this would be the final answer. Okay, so let's proceed with question letter B. Find y double prime, or the second derivative of the implicit function xy is equal to 32. So this is in the form of product. So take note of the product here. So therefore we have the product is in terms of u dv over dx plus v du over dx. So first is you have to copy, and this is our u and this is our v. So copy x and derivative of y. Since it's implicit, this become y prime plus copy v, which is our y, times the derivative of x, which is 1, and the derivative of 32, that is 0. So we have x y prime is equal to negative y, and y prime is equal to negative y over x. So this is our first derivative. Since we need to take the second derivative, so let's proceed. So this is our u and this is our v. So this is in the form of v du over dx plus minus u dv over dx over v squared. So first is we need to copy for our second derivative. So we need to copy v. The v here is x times the derivative of negative y is negative y prime minus, what is our u? Our u here is negative y times the derivative of x is equal to 1 over the v squared is x squared. So since we need to take the second derivative, so we need to replace y prime here. So negative y prime is equal to this part. So we need to substitute. So x, so since it's negative, so negative y prime is equal to negative times negative y over x. So this will become y over x. So the result now says from here negative 1, negative y prime, that is y over x. Na-repeal na po yung negative sign. Because negative and proceeded with negative, it will become positive. So that is y over x plus this come y over x squared. So cancel this part. So y double prime is equal to y plus y, that is 2y over x squared. So this is the second derivative of the implicit. Okay, so let's proceed with number 3. So this is x squared plus y squared is equal to 4. Our number 2 rather, x squared plus y squared is equal to 4 and y double prime. So first is we need to take the derivative in terms of implicit function differentiation. So this is 2x plus 2y y prime is equal to the derivative of this one is equal to 0. Let's go back. So this is 2x and 2y prime, since that is implicit function. So 2y y prime. And we need to get the y prime, so therefore we have 2y y prime is equal to negative 2x. So y prime is equal to negative 2x over 2y. The result is y prime is equal to negative x over y. So this is the first derivative. So since we need to take the second derivative, so this is the form of u over b. So we need to apply v du over dx minus u dv over dx over v squared here in order to find the second derivative. So second derivative, copy v, which is y. And the derivative of u is negative 1. Minus, copy the u, which is negative x. And the derivative of y is equal to y prime over y squared. So since we have here the y prime, we need to equate this one here, and that is the result or the equivalent for y prime. So we need to substitute double prime, so negative y plus x raised to negative x over y. So the result of this one is negative x over y all over y squared. So y second derivative of y is equal to, this is negative y minus x squared over y squared. So next we have to simplify. Double prime is equal to, simplify first, this is y, and y divided by 1, this y times negative y, this is y squared minus x squared over y squared. So we'll rewrite here y double prime is equal to, we could refactor this one, this will become negative y squared plus x squared over y, and take the reciprocal of this one, 1 over y squared. The reciprocal of this word, that is 1 over y squared. Since y squared plus x squared, we have here the equivalent of this one is x squared plus y squared, and this is part of the first equation that we have, that x squared plus y squared is equal to 4. So we have x squared is equal to, x squared plus y squared is equal to 4. We have to substitute this 1. So y double prime is equal to the result of this one is negative 4 over y times 1 over y squared. So therefore, double prime is equal to negative 4 over y cubed. So this is the second derivative. Okay, let's proceed to number 3, which is y squared minus 16 is equal to 0. And we have to find the second derivative of the implicit function y squared minus 16x rather. This is 16x. Okay. So y squared minus 16x is equal to 0. So first is we have 2y prime minus 16 is equal to 0. So y prime 2y prime is equal to 16. So y prime is equal to 16 over 2y. So y prime is equal to 8 over y. So this is the first derivative. So since it's in the form of u over v, so apply this one. V du over dx minus u dv over dx over v squared. So we have to apply this formula. So to get for double prime, so first we have to v. So v is copy and derivative of u is 0 minus copy the u, which is 8, times the derivative of this one is y prime over our v is y squared. So what is the result of y prime? So we need to substitute here coming from the first derivative. So second derivative is equal to negative 8, this is 0, times 8 over y squared. So this is y double prime is equal to negative 64 y times the reciprocal of this one, y over y squared. So y double prime is equal to negative 64 over y cubed. So very easy. This is our second derivative is equal to negative 64 over y cubed. Okay, so try this one at home. Find y double prime or second derivative if 4x squared plus 9y squared is equal to 36. So you have to show your solution if you have, and just comment your answer on the comment box. Thank you and God bless everyone.